My name's Adrian Jackson, and I'm from EPCC, which is part of the University of Edinburgh. We are the UK's national supercomputing centre, and actually we've been doing large-scale compute in Edinburgh and in UK academia and research for a very long time. Of course, it looked a lot better back in the past, and it's a shame we can't get some of these machines like the Connection machine or some of the Crays that are all being hosted in Edinburgh, but also other places around the world, back into style these days, because we have a large data centre, we run large systems, but they're nowhere near as pretty as these systems that we had in the past. So we have nice stickers on the front of them, but they don't go to the flashing lights and bench seating that some of the Cray supercomputers used to have. But really, what's useful, what's interesting from my perspective is that large-scale compute is one of these things that has been around for a long time. So we have had a long history of it. In Edinburgh, from the early 80s, we've been running very big systems. Obviously, some of the very largest systems and the most innovative systems have come out of academic research, because for a long time, this has been the driver of compute requirements and compute capacity. We have worked with a small set of domains for a long time, mainly the physical sciences, where they've really always needed more compute than you could provide them. Always fill up our systems. But the amazing thing that happens nowadays is this has expanded really into all aspects of our life. So things that were very niche and very specific to research and to a very small number of places have become ubiquitous and clearly very important to innovation and to the economy and to everything else. The other thing that's really happened is there's been a step change in compute technology. So this is what's enabled AI. This is really what's enabled the generation of data, but also the step change in compute technologies has enabled us to be able to develop and use these AI systems. And really interestingly, these kind of systems we had here, actually, we could run. They needed large rooms, they needed special facilities, but they didn't need lots of electricity. We could run these inside our university buildings, and actually most of the time we were running these systems, we didn't have them in a data center. We just had them in a room, a data room, in our engineering campus, our science campus on the south side of Edinburgh, called King's Buildings. But we had to move away from that about 25 years ago, partly because people kept breaking and stealing parts of these computers, because it was a room, it was a building where we had students and we had public access, and over time the insurers said, no, you can't keep doing this. But mainly because actually over time we couldn't get enough electricity into the buildings to support these kind of things. So the reason that we can be the UK's national supercomputing centre, and the reason that we can provide these services to industry and to academia, is we have our own data centre. I have our own data centre on the south side of Edinburgh, actually out in the countryside. And this is what we are using to provide large-scale compute capacity to the UK. And really, that expansion of electrical requirements, the expansion of power and energy needed to run large-scale systems has driven us to have to develop over time as well. So now we have a system with 4 machine rooms, and our biggest has just been developed down here. That's a 30 megawatt room for our upcoming supercomputer, which Amanda mentioned. And that really is sort of a step change for us and for UK research computing, because it's this large-scale, dense, liquid-cooled, requiring large amounts of energy. So as I said, this is a 30 megawatt facility now, with another 30 megawatts of power in there just for the cooling side of it as well. And that lets us run very large computers. And indeed, the next national supercomputer for research in the UK will be coming to Edinburgh and is going in that dedicated room that's been built for it. This is a system that has actually been delayed over time, and at one point was cancelled by the Labour government when they came into power, and then came back again, but will be delivered next year. It's in procurement at the moment, and will be coming to Edinburgh and be installed in that building for us to provide services to the rest of the UK. So it's not our computer, it's not for us to use, it's for us to operate and provide, so that UK research can stay at the forefront of global research, and it has the resources it needs to do the research through modelling, simulation and AI using this kind of hardware. Now, traditionally, we have not been running large-scale AI workloads. We've not been running large-scale AI jobs because that's not where the research has been. It's all been simulation and modeling, but really we are seeing this convergence now of AI which can provide functionality that is efficient and useful for parts of our simulation, and modeling and simulation that is still required. And examples of this are like the picture on my bottom left is from ECMWF, the European Centre for Medium Range Weather Forecasting, who have spent the past few years developing an AI surrogate model to do their weather forecasting. It hasn't replaced their normal forecast model, but it is something which supplements it and allows them to do additional work, additional research, additional data products and generate those. On the right-hand side, this is radio astronomy, and it's imaging for radio astronomy, and that's often been computationally very expensive, and we can replace parts of that pipeline with learned models, which let us move away from, or let us do more high resolution, more precise image generation without using the same amounts of compute power before. Now, the large-scale supercomputer that we'll be deploying is not designed and is not provided to do large-scale AI training, because we are moving now into this domain where inference is going to become more important than training. So there are UK research resources, computers that are dedicated to training new models. But what we're going to see on this next computer will be people using models for inference, deploying those models for their science, for their research. Having said that, it will be built from the same kind of hardware, right? So our next big supercomputer will be built from something like the NVIDIA Vera Rubin or the AMD MI430X GPUs. It's just we will build and configure it in a different way than if you were doing that for a big, large-scale training system. We have also a long history of AI research in Edinburgh. In fact, the informatics department has often been world-leading in the AI research it does. And we at EPCC also run a large-scale system for AI training. So there's something called the Edinburgh International Data Facility, which is funded through the Edinburgh City Deal and the Data-Driven Innovation Initiative, which is a £1 billion investment in Edinburgh across 10 years to make Edinburgh the data capital of Europe. And here we have a large-scale GPU cluster where people are coming to us to do training and development of AI functionality. And we also provide innovative AI hardware as well. So we run Cerebrus CS3 systems, we run TENS Torrent accelerator systems as well. And this brings me on to the sort of final thing that I think is interesting in this community. We are now also starting to link up with the European activities in AI, in AI development and provision. So Europe is investing very, very largely in AI, very significant AI factory and AI gigafactory investments. There's over 10 billion euros gone in already to the AI factories. And we are running what's called an AI factory antenna, which is a connection between the UK and the European AI factory ecosystem that lets us bring people in the UK and get access to those compute resources elsewhere. We are closely coupled to one of the German AI factories called Hammerhai, and we're running this project called Pilot, which is a large-scale project over the next 3 years to enable SMEs and industry to get access to these resources to develop their AI techniques and technologies and then move on from there. So we're not attempting to replace large-scale commercial provision of AI resources, but we're trying to enable businesses to take AI approaches, to experiment with them, to get access to big computing technology if they need it, and then to move on to embed these activities in their overall portfolios. And so if you're interested in that at all, we are running projects with companies where we work to develop AI functionality for them. So in some ways, the UK research community is quite separate from business and industry, but we have this long heritage, this long history of developing large-scale compute infrastructure and large-scale compute capacity, and I think there's a lot to be learned from working hand in hand between industry, between academia, to develop the next generation of AI technologies and the next generation of compute hardware. So if you're interested in that at all, come and talk to us. We're more than happy to collaborate with people. And I will leave it there.